Hi students, today we are going to continue that carbonyl compounds. Yesterday we have prepared some ketones and aldehydes, right? Today some important naming reaction we are going to see to the preparation of aldehydes. The first reaction is Rosenman reduction. Rosenman reduction. Reduction means addition of hydrogen. Okay. So here we are going to use the catalyst palladium barium sulfate. So palladium only the catalyst, but we need to apply limited amount of palladium. For that we are using as a catalytic poison barium sulfate. Right. So reason I will tell. CH3 acetyl chloride C double bond O Cl. What's the name of this one? Acetyl chloride is treated with hydrogen H2 we can say. The presence of palladium barium sulfate. So what will happen? This hydrogen, two hydrogen we can write H like this. One of this hydrogen will combine with this C chlorine, it will go as a hydrochloric acid. Then we can add this hydrogen at the place of Cl. So what will be the product? CH3 C double bond O H. So acetaldehyde or ethanol we will get aldehyde ethanol with HCl. So here I told barium sulfate act as a catalytic poison. Why this is catalytic poison means if you leave it without adding this barium sulfate, we cannot get this aldehyde. Further it will undergo the oxidation, it will produce acid or further it will reduce into alcohol. Okay. So this is a reduction reaction. So further it is undergoing the reduction. It will give ethanol. Primary alcohol will form. So we want to stop with aldehyde means we must add barium sulfate as a catalytic poison. Okay. So in this process we can prepare aldehydes. We cannot prepare the ketones and also formaldehyde. Formaldehyde chloride is a unstable compound, so formaldehyde we cannot prepare. The second one is important reaction, another naming reaction, Stephen's reactions. So Stephen reaction, we are going to take some cyanide compounds, okay, cyanide compound in the presence of stannous chloride SnCl2 with HCl, we will get some intermediate. It means further on hydrolysis it will get aldehyde. So what? CH3Cn, you can write triple bond N. Cn simply we can write C triple bond N. This is called ethane nitrile. Why this is called ethane nitrile? 2 carbon. Cyanide means nitrile. The place of it is reacting with the catalyst stannous chloride and HCl. Right? So it is another reduction reaction. Reduction means we can add hydrogen. So we are going to add 2 hydrogen. So in that one hydrogen will add in the carbon, another hydrogen add in the nitrogen. So the triple bond will reduce into double bond. We will get one intermediate, not a product. CH3 CH double bond NH. This is called imine product. That is called imine, IMMEN, imine product. Okay. Further on, reaction with hydrolysis. See, this is water with acid. H plus means acid. In your book, that is given H3O plus. H3O plus nothing but H2O with H plus. Okay. Now what will happen? Very simple. In the water, we have hydrogen and oxygen. Hydrogen two hydrogen is added in the nitrogen, oxygen added in the CH group, so the double bond will break. So what is the product? CH3 CHO, CH3 CH this O. So aldehyde we will get, along with that NH plus 2 hydrogen, NH3. See the same Stephen reaction given in the old book. In that we have to bring the ammonium chloride, NH4Cl. So here we have taken the Cl also, that will add with NH3. So we can get NH4Cl as a ammonium chloride, NH4Cl. Then the next reaction, selective reduction. What is selective reduction? The same type of a CN group, but we are going to take the different types of a catalyst. Okay, so we are going to take CH3 CH double bond CH CH2 CH2 CN. Who will tell the name of this compound? Count it, 1 2 3 4 5 6. So hexane, right? So fourth carbon, 1 2 3 4, fourth carbon having double bond, so 4 ene nitrile. So hex 4 ene nitrile is the name of this compound. Then we are going to take the different types of catalyst, that is diisobutyl aluminum hydride. Diisobutyl aluminum hydride. So how will you write? Diisobutyl aluminum hydride. The short form only written DIAL -H. Okay. So if you use this catalyst, followed by we have to use the hydrolysis also. Here we use to hydrolysis, same way. Then what will happen? As usual, we can have the same manner. Only the thing here we will get CHO group. How? See, we have the water molecule. If you take 2 water, okay. How will you write the 2 water molecule? Usually, how will you write the water molecule? HOH. So if you take 2 moles of water molecule, how do you write? HOH, HOH. So this nitrogen will go along with NH2OH, hydroxylamine. The remaining OH will be added here. So you will get the product CH3, CH double bond, CH, CH2, CH2, CHO. I am writing here again CH3, CH double bond, C. Just up to here you can copy CH, CH2, CH2. Then COH, the remaining COH will add. So plus NH2OH. NH2OH is called hydroxylamine. Okay. So here, even though double bond present, we are doing the reduction. That's why this is called a selective reduction reaction. Next reaction we are going to load from the toluene. We are going to prepare the toluene to benzaldehyde. So we are going to prepare aromatic aldehyde. Wherever we have the benzene ring, we can say aromatic. So from toluene, the name of the reaction is important. Ettard reaction. Why I am saying this name and all means they will ask the name of the reaction. Ettard reaction means from the toluene. Toluene means benzene ring with CH3 group. One benzene ring with one CH3 group present means we will say toluene. Otherwise we can call it phenyl methane. This phenyl or methane. It is treated with chromyl chloride. The catalyst name is chromyl chloride, CrO2Cl2, or we can take chromic oxide, CrO3, right? So chromyl chloride, if you take, what will happen? It will form one intermediate. See, there is three hydrogen, you know. Two hydrogen combined with these two oxygen, it becoming OH group, right? So actually what will happen? This structure you can write like this: C double bond Cl. Actually, this is a structure of a chromyl chloride. Now, what will happen? There is a three hydrogen. You know, one hydrogen will combine with this oxygen. It will form OH group. Then this bond will connected with this C. The same way we want to take two moles. So two chromyl chloride will attach with this CH3 group. So likewise, CH is connected with the OCrOHCl2. OCrOHCl2. But in your book there is a mistake. They are not given twice. In your book they are given only this group, but they have to give two here. Twice not given the book. Make it. Then as usual, hydrolysis H3O plus. H3O plus means H2 and H plus. So H2O. How do you write the H2O? Very simple. This hydrogen will combine with this OH. Two hydrogen. Actually, two chrome oxide group is there, you know. So water OH2, like you can split. Now oxygen you can add here. The hydrogen will combine with this remaining group. So now you will get the product CH2O. That is nothing but aldehyde group. So this ring, without forget, you have to draw. That is also important. So benzene ring with aldehyde, that is called benzaldehyde. Okay, or phenyl methanol. That is also IUPAC's name of the compound. Benzaldehyde or phenyl methanol. See here, all those explanation they may not given the book, right? If you drawing like this means it is easy to learn. Okay, then we are going to learn the next preparation, Caterman-Koch reaction. Caterman-Koch reaction also like Friedel-Crafts reaction. From benzene we are going to prepare the benzaldehyde. Caterman-Koch reaction. Caterman-Koch reaction, we are going to take benzene. So with the benzene we are going to take the catalyst. What are the catalysts you want to take? Carbon monoxide HCl along with that aluminum chloride and copper chloride, right? AlCl3. These are the Friedel-Crafts catalyst. Only this group will undergo reaction with this benzene ring. What will happen? Very simple. We want to prepare what? CHO group. So if you see all the corner we have one hydrogen, but for writing purpose we are not indicating. If anything is added in the corner, we can remove that hydrogen. So already we have one hydrogen here. This hydrogen will combine with the Cl, will go as a HCl. What's the remaining? CHO. So we will get the product CHO plus HCl. So we got aldehyde. What's the name of the compound? Benzaldehyde. Caterman-Koch reaction. The next one is from toluene to benzaldehyde. How do you prepare toluene to benzaldehyde? What is the molecular formula for toluene? Benzene ring with CH3, right? So here we are going to take halogen, okay, Cl2 along with the photolytic reaction. That means presence of a light. H mu indicates presence of a light. So what will happen? See, actually we want to take 2 moles of Cl2. Totally we have 4 Cl, 2 Cl, 2 Cl. Like we can separate, right? Here we have 3 hydrogen, you know. Separately take it 2 hydrogen. The 2 hydrogen will combine with the 2 Cl. It will go to HCl. The 2Cl, the place of 2 hydrogen we can add. So from the 3 hydrogen, 2 combined with 2Cl, it will go as a HCl. 2Cl we can add it. So what is the product? Benzol chloride, CHCl2. What is the name of the compound? Benzol chloride. Right? Further, it is reacted with water under the temperature 373. It is reacting with water H2O and then 373 Kelvin temperature. What will happen? Very simple. This Cl2 will combine with this hydrogen. It will go as a HCl. O will add here. So we will get our expected product benzaldehyde plus HCl, 2HCl, right? So we have removed 2 hydrogen, added 2Cl. Then the 2Cl removed with the hydrogen in the water, it is removed as a hydrochloric acid. Oxygen is added here, so we got the benzaldehyde product. Okay. Then we are going to prepare some ketones. Aldehyde we have prepared, the same way we are going to prepare some ketones. So first we are going to treat some chemical compounds acetyl chloride with dimethyl cadmium. What's the molecular formula for acetyl chloride? CH3COCl. CH3COCl plus what is the molecular formula for dimethyl cadmium? CH3CdCH3. We are going to take another one mole of same acetyl chloride. So plus Cl, C double bond O, CH3. Right? So why I am writing this like structure means it is important because we are going to remove this Cl, this cadmium, this Cl becoming cadmium chloride. Now what will happen? This CH3 will add here, this CH3 will add here. So we will get 2 moles of acetone. What is the product now? CH3, C double bond O, CH3. CH3, C double bond O, CH3. Plus here also another one. Simply we can make it 2 times. Plus what are the another product? CdCl2, cadmium chloride. So we will get the product acetone or propanone, right? Next we are going to prepare acetophenone. Acetophenone, how will you prepare? By Friedel-Crafts reaction. It's also important. Friedel-Crafts reaction. So the names are important. You must know the names, then only you can easily understand. So always the catalyst for Friedel-Crafts is aluminum chloride with some chlorides and water. Okay. So here we are going to take benzene. Benzene reacted with acetyl chloride. Already we know that C double bond O, CH3. What is the catalyst? Aluminum chloride with water. So how it will form acetophenone? Very simple. We can take this hydrogen just to remove as a hydrochloric acid. You add the remaining COCH3. The product is acetophenone. Listen, here COCH3 added. If you add COCH3, so what is the name of this compound? This is phenyl group, methyl group. So acetophenone, right? IUPAC name, how will you call? Phenyl methyl ketone, or we can call it phenyl methyl ketone. We already written the IUPAC name of this compound. What is that? acetophenone. Okay, then 1 2 or 1 2 1 phenyl 1 methyl ketone, that are methanone, that is also another name. 1 phenyl 1 methyl, both considered as a, sorry, one is a branch parent chain, so 1 phenyl what, ethanone, right? The same way we are going to prepare benzophenone. The place of the CS3, if you write C6H5, that means another benzene, you will get benzophenone. See, the same, just you can copy the above reaction, right? Plus Cl, C double bond O. The place of CS3, right? C6H5, same catalyst. Then what happened? This hydrogen will combine with the Cl, will go as a HCl. You add the remaining, you will get benzophenone, C6H5. CH3 means acetophenone, C6H5 means benzophenone. Both are important compounds, right? Aromatic ketones, that is also there. Benzene ring, ketone functional group present, so both are exempt for aromatic ketones, right? So all preparation of aldehyde ketone over. Now we are going to learn about some physical properties of aldehyde and ketones. So first physical property, physical state, okay? Formaldehyde, the smallest aldehyde, formaldehyde. Formaldehyde, gaseous state, right? Then acetaldehyde, volatile acetaldehyde, 2 carbon aldehyde, sorry, acetaldehyde, 2 carbon aldehyde, volatile liquid, okay? All remaining are colorless liquid. Some of the high members are solid, that means more number of carbon with aldehyde means they are in the solid state, okay? Then boiling point, okay? So aldehyde having high boiling point than hydrocarbon and ether. Hydrocarbon means without any functional group, ethane, methane, propane, there is no alcohol or acid group, okay? Simply methane, ethane, propane called hydrocarbon. They are having high boiling point than carbon and hydrocarbon and ether, but they are having less boiling point than alcohols and other compounds, because alcohols having the hydrogen bond, okay? So which is also dipole interaction. This compound having dipole interaction. What even dipole interaction? See, usually how will you write the carbonyl compound? C double bond O, right? So because of electronegative character of this oxygen, it will attract this bonded electron. So what will happen? It will form C plus and O minus. Already we have seen. Because of this nature, they are having dipole interaction. So some other thing, carbon comes means, suppose another carbon means there is an interaction between this one. That is only called a dipole interaction. Okay. Then they are given many of the boiling point and melting point in the box. Okay. So we know that hydrocarbon having least boiling point. Then aldehydes next to that alcohol. Okay. Then what about the solubility? How it is dissolved with water? Okay. Aldehydes are low members like ketones like formaldehyde, acetaldehyde, acetone. They are miscible. Low members means with 1 carbon, 2 carbon. Aldehyde ketone will dissolve, but high members will not dissolve because they are having the hydrogen bond. Low members will dissolve. Okay. For example, R C double bond O R, then another aldehyde. If you see the water, how water will form? HH. Okay. So there is an interaction minus plus minus plus minus. So this minus plus will have the interaction because of that hydrogen bond. Already we have studied the hydrogen bond in the 11th standard itself. The interaction between the electronegative element and the hydrogen. Okay. Then dipole moment. What do you mean dipole moment? Already we have seen, if you see the high electronegative character, it will attract the electron towards the oxygen. That attraction makes a negative positive charge. So if we find the dipole moment which having some amount of dipole moment, right? Now we are going to learn about chemical properties, how they are reacting. Okay, chemically how they are reacting we are going to learn now. Okay, the first one is nucleophilic addition. Nucleophilic addition, right? So nucleophilic addition means what? We are going to add the nucleophile. Okay, so nucleophile example. First tell me what is nucleophile. Nucleus attracting element or group only called nucleophile. Phile means attraction. Okay, so which one will attract? Phile. Okay, nucleophile means attraction. Nucleus attraction means nucleus positive charge. Which one will attract the nucleus? Negative charge. So the negative elements only called nucleophile. The simply nucleophile represented Nu minus. Again I am saying the negative group only called nucleophile. Okay, right. So example we can write cyanide. Okay, Cn. Now we are going to treat how the aldehyde and the ketones reacting with the nucleophile. What is the mechanism? R, C, or double bond O. If nucleophile minus comes means what will happen? Because of this electronegative character of oxygen, always it will attract the bonded pair electron. So now the carbon can be carry the positive charge, so the positive charge will attract the negative charge. So what will be the product? R now new one nucleophile O minus. Okay, then if you go with the hydrolysis, water hydrolysis means it will give H plus and OH minus ion. Okay, so this H plus will add here, so we will get alcohol product. What product will get, my dear students? Alcoholic product. Okay, so in this method we can prepare many compounds. Okay, see R, the place of R we are going to substitute many organic compound. If you substitute, we will get the appropriate products. The first one we are going to take the nucleophile hydrogen cyanide HCN. Okay, with acetaldehyde CH3 C double bond OH. The same reaction already what we have seen in the nucleophilic addition, the same, plus HCN. Then what will happen? Listen, it will carry the positive charge or negative charge, and also it will dissociate them. From this HCN we will get the cyanide Cn minus as a nucleophile. Then what will happen? It will attack this carbon, it will carry the minus charge. So what is our next product? CH3C, already we have hydrogen here, O minus, then Cn is added. When added, you should not write Cn minus because that minus only used as a bond, so Cn only you want to write. But here we have the minus charge, which is not a completed product. So further we can, already one H plus emitted from the HCN, that hydrogen we can write here. So it will add. So what is the product? CH3 CH Cn then OH, right? So what is the name of this compound? Hydroxypropane nitrile, because nitrile 3 carbon propane OH group present hydroxypropane nitrile. Okay, This is also called some 2-hydroxypropanenitrile. Why? The second carbon, 1, 2, 3, second carbon having OH group. So 2-hydroxypropanenitrile. Then we are going to add another nucleophile, that is sodium sulfide. So sodium bisulfate, NaHCSO3, right? So the Na will go out, the remaining we can get as a nucleophile. From that, HCN gives a Cn minus nucleophile. Here Na plus and HCSO3 minus. So this you can write OSO2H. Both are same. Okay. Now the same. Here we are going to take ketone, acetone, C-O. First case we took aldehyde. Here ketone. It is treated with this OSO2H minus. As usual, it will attack the carbon. It will go as a minus. Then CH3. Here O minus. What is the new one? OSO2H. As usual, addition of H plus from the water. So the H plus will form bond with the hydrogen. So what is our product? CH3, CH3, OH, OSO2H. So this is the way we can prepare the compound. Further, it is on reaction with the Na plus. What will happen? Here the SO3H, you know, it will attract this hydrogen. By removing this hydrogen, we can add Na also, right? So, or we can say in this reaction, this H will go and form OH minus, OH. The remaining SO2 minus will attract this Na plus. So last we will get CH3, CH3, OH, OSO2, Na. Next to this. Okay. Right. Actually, next we have to add alcohol. Okay. That alcohol addition we will see in the next class. Thank you.